Hello, geometry students. So today we're going to talk about the properties of parallelograms. First of all, the definition of a parallelogram. A parallelogram is a special case for a quadrilateral. So it's a quadrilateral, it has four sides, but it's a special case. And the parallelogram's definition states that it's a quadrilateral where both pair of opposite sides are parallel to each other. So you can use that definition to find x and y in this diagram based on what you already know about parallel lines cut by a transversal and triangle sum. So pause, practice, and press play. We know the definition is of a parallelogram is both pair of opposite sides are parallel, so we can mark our diagram. And we know that parallel lines cut by a transversal alternate interior angles will be congruent. And since there are two pairs of alternate interior angles, we can make two z's, and then we can use triangle sum to find x and triangle sum again to find y. So before I go on to the theorems about parallelograms, we need this vocabulary to be solid. Opposite sides of a shape are shapes or are sides that do not touch, they do not share a vertex. And opposite angles, like A and C here, are angles that are across the shape, they do not share a side. Consecutive sides, on the other hand, are sides right next to each other. They're sides that do share a vertex. Just like consecutive angles are angles right next to each other, they're angles that do share a side. So we need that vocabulary for the first theorem. So if we know we have a parallelogram, a quadrilateral is a parallel. If a quadrilateral is a parallelogram, then we know consecutive angles will always be supplementary. And notice there are four pairs of consecutive angles: A plus B, supplementary; B and C, supplementary; C and D, supplementary; A and D, supplementary; A and B, supplementary. So four different pairs of consecutive angles inside any parallelogram, and they're all supplementary. So pause, use this theorem, and find your unknown, find x. Given it's a parallelogram, we can use the theorem that if it's a parallelogram, then consecutive angles are supplementary to set up our equation. These are consecutive angles, so 60 plus x has to add up to 180. These are also consecutive, so they have to add up to 180. And you can find out x is 120. Next theorem for parallelogram. If a quadrilateral is a parallelogram, then the opposite angles are congruent. And so if you know you have a parallelogram, both pair of opposite angles will be congruent. So A and C are congruent and B and D in this diagram. So pause, use that theorem to find A. We're given it's a parallelogram, so we can mark our diagram, and then we can use our theorem that says if it's a parallelogram, then opposite angles are congruent. So those two algebraic expressions have to be equal. We can set them equal and solve for A. Next theorem. If a quadrilateral is a parallelogram, then opposite sides are congruent. So if we have a parallelogram, then both pair of opposite sides will be congruent. So pause and use that theorem to find x. And then plug it in to find the measurement of DC. Because of the marks on the diagram, we see we have a parallelogram, and therefore we can use our theorem about parallelograms that states if it's a parallelogram, then opposite sides are congruent. So therefore we can set these two algebraic expressions for those lengths equal to each other, and we can solve for x. Once we have x, we can plug it in to get our measurement for DC. And here we have a final theorem. If the quadrilateral is a parallelogram, the diagonals will bisect each other. They will cut each other in half. So if you have a parallelogram, those diagonals will chop each other in half, meaning AC gets bisected, gets cut into two congruent chunks, and BD also gets bisected. It also gets cut into two congruent chunks. So pause and solve for X and Y using this theorem. So given it's a parallelogram, we can mark our diagram accordingly. And then we can use our theorem that states that if it's a parallelogram, the diagonals will bisect each other, which means these two chunks will be congruent and these two chunks will be congruent because the two diagonals, KM and LN, bisected each other or cut each other in half. And so I can set up this system of linear equations. You could use your calculator to solve the system, or you could solve by substitution, which I'll model here. You can solve the system of linear equations by substitution because x equals y plus 2. So whenever I see x in the other equation, I could, instead of x, I could write y plus 2. Could make that substitution. And then I would only be dealing with y's, so I could solve for y. Distribute, combine like terms, get your variables on the left, your numbers on the right, and isolate y. Once you have y, you can plug it into either of the original equations to find x. So your final solution is x is 16 and y is 14. So here is a summary, the definition of parallelograms and the 4 theorems that we discussed about parallelograms. So you could take a picture of this summary page if you like. And I will leave you with this happy picture of a field of daisies, and I will wish you a great day.